Battery science brings us two of technology's greatest gifts, portability and knowledge. If there were no batteries, then there would be no cell phones, no laptops, no pocket calculators, and no transistor radios. However, the greatest gift that batteries have given us is allowing us to turn off coal, gas, and nuclear power stations and live a greener, more efficient life. A battery is a device that stores chemical energy for later release as electricity. Batteries are a collection of one or more cells whose chemical reactions create a flow of electrons in a circuit. All batteries are made up of three basic components: an anode, the negative node, a cathode, the positive node, and some kind of electrolyte, a substance that chemically reacts with an anode and cathode. When a battery is connected to an external electric load, a reduction-oxidation reaction converts high-energy reactants to low-energy products. This reaction causes electrons to flow through the circuit and back into the cathode where another chemical reaction takes place. In this presentation, I'll be going into detail about one specific type of battery, the lithium-ion battery. Lithium-ion batteries are used by millions of people every day. They are used in applications from mobile phones and laptops to even hybrid and electric cars. So what are lithium-ion batteries? Most lithium-ion batteries share a similar design consisting of a metal oxide cathode coated onto an aluminum current collector, an anode made from carbon and/or graphite coated on a copper current collector, a separator, and an electrolyte made of lithium salt in an organic solvent. While the battery is discharging and providing an electric current, the electrolyte carries positively charged lithium ions from the anode to the cathode and vice versa through the separator. The movement of the lithium ions creates free electrons in the anode, which creates a charge at the positive current collector. The electrical current then flows from the current collector through a device being powered to the negative current collector. The separator blocks the flow of electrons inside the battery. During charging, an external electric power source applies an overvoltage, forcing a charging current to flow within the battery from the positive to the negative electrode. The lithium ions then migrate from the positive to the negative electrode, where they become embedded in the porous electrode material in a process known as intercalation. In a lithium-ion battery, the lithium ion moves between the positive and negative electrodes. The positive electrode consists of lithium cobalt-3 oxide, and the negative electrode is highly crystallized graphite. To complete the battery, an electrolyte is needed, which can consist of an organic solvent and ions. In the charging cycle at the positive electrode, lithium ions are released into the electrolyte solution as electrons are removed from the electrode. To maintain a charge balance, one cobalt-3 ion is oxidized to cobalt-4 ion for each lithium ion released. At the negative electrode, lithium ions enter between the graphite layers and are reduced to lithium metal. This insertion of a guest atom into a host solid is called intercalation, and the resulting product is called an intercalation compound. Although lithium-ion batteries are by no means perfect, the environment is one of the biggest benefactors when it comes to using lithium-ion batteries and technology. On the next few slides, I will list just a few reasons why these batteries are more sustainable for the environment. To start, lithium-ion batteries are in fact rechargeable. Having batteries that can be charged many times and that last and continue to power devices means we are less reliant on one-use alkaline batteries that are more detrimental to the environment. Next, these batteries have a maximum energy output. This means lithium-ion maximizes the output of energy from any device. A good example is a simple flashlight, which has evolved to become much brighter and much more efficient due to lithium-ion batteries. Lithium-ion batteries are also lighter weight. This is important for small gadgets that we use on a day-to-day basis, but is also great when thinking about environmental factors and transportation. Recyclability is a bit more questionable as to how much of the battery can actually be recycled. However, it is getting better and better as the years progress. This means that it has the potential to be recycled, unlike fossil fuels. 95% of lithium comes from pumping underground brine into pans, then allowing the liquid to evaporate. After this, they separate the lithium using electrolysis, which is a much less destructive mechanism than mining methods for fossil fuels. Moving on, the lithium-ion battery has quite a long life. For example, an average lithium-ion car battery can last for around 6 years, which is a serious amount of time before you need to think about recycling. Lithium-ion batteries can also be charged pretty fast compared to alternatives. This means less energy charging over long periods of time. Despite its overall advantages, the lithium-ion battery has its drawbacks. It is fragile and requires a protection circuit to maintain safe operation. Built into each pack, the protection circuit limits the peak voltage of each cell during charge and prevents the cell voltage from dropping too low on discharge. Firstly, the biggest disadvantage of the lithium-ion battery is the protection required. They require protection from being overcharged and discharged too far. In addition, they need to have the current maintained within safe limits. They require protection circuitry incorporated to ensure they are kept within their safe operating limits. Fortunately, with modern integrated circuit technology, this can be relatively easy incorporated into the battery, or within the equipment if the battery is not interchangeable. Incorporation of the battery management circuitry enables lithium-ion batteries to be used without any special knowledge. They can be left on charge, and after the battery is fully charged, the charger will cut the supply to it. The second disadvantage is in transportation. Many airlines limit the number of lithium-ion batteries they take, this meaning their transportation is limited to ships. For air travelers, lithium-ion batteries often need to be in carry-on luggage, but the number of batteries may be limited. Any lithium-ion batteries carried separately must be protected against short circuits by protective covers. It is particularly important where some of the large lithium-ion batteries, like those used in large power banks. Lastly, a major lithium-ion battery disadvantage is their cost. Typically, they are around 40% more costly to manufacture than nickel-cadmium cells. This is a major factor when considering their use in mass-produced consumer items where any additional costs are a major issue. So the question is, are lithium-ion batteries sustainable? Lithium is the go-to choice when it comes to battery production today due to its lightweight and its excellent electrical conductivity. A recent study has shown that these batteries can withstand temperatures up to 80 degrees Celsius, allowing them to withstand more intensive activity with less loss of battery life. These advantages have made lithium extremely important in today's energy storage industry. The usage of lithium-ion batteries has increased massively in the past 2 decades and is expected to increase by 10 times as much in the next decade. Despite its efficiency as a battery, there are still ongoing debates on lithium batteries' environmental friendliness due to its extraction method. Lithium is extracted through water mining, which requires an enormous amount of water. Throughout the process, and toxic chemicals are needed to process lithium, leading to frequent water contamination and shortage in lithium-producing countries. To finish off the presentation, let's talk about some of the most important real-world applications of these batteries. Lithium batteries have a long list of applications beyond running the apps on your phone. These range from various types of medical equipment to yachts and electric cars. Rechargeable lithium batteries are well known for powering our phones and the latest lightweight laptops. Lithium batteries are lighter and smaller than lead-acid batteries. They also tolerate movement and temperature changes, as well as maintaining their power delivery during use. When the lithium-ion battery in your mobile phone is powering it, positively charged lithium ions move from the negative anode to the positive cathode, and the electrons move from the cathode to the anode. The lithium-ion battery in electric vehicles circulates electrons by creating a difference in potential between two electrodes, one negative and the other positive, that are immersed in the electrolyte. When the battery is powering a device, the electrons accumulated in the negative electrode are released via an external circuit to travel to the positive electrode. This is the discharging phase. Conversely, when the battery is charging, the energy supplied by the charger sends the electrons back from the positive electrode to the negative electrode. The last application I'm going to cover is medical equipment. Lithium-ion batteries were first used in pacemakers during the 1960s and are now used in all kinds of medical equipment, including automatic defibrillators, surgical saws, drills, bone growth simulators, glucose monitors, blood oxygen meters, and many more. Lithium-ion batteries also offer an extended temperature range, made possible by the absence of water and the chemical and physical stability of the materials. Lithium thionyl chloride cells provide the widest temperature range of all and can be specially modified to withstand temperatures as low as -80 degrees Celsius to support the medical cold chain, delivering continuous power even at extremely cold temperatures to permit around-the-clock monitoring of pharmaceuticals, transplant organs, and tissue samples that are frozen or packed in dry ice. Before I conclude, I'm going to test your knowledge with a few quick questions regarding what we've discussed. Pause the video now and give each question a try. Okay, so first we have, what metal is commonly used at the cathode of a lithium-ion battery? The answer to this is cobalt. Next, what is the process of lithium ions moving between the cathode and the anode called? I discussed this in slides 4 and 5. The answer to this is intercalation. Next, what is one benefit of lithium-ion batteries? There's many to choose from, but I chose recycling, rechargeability, maximum energy output. And lastly, what is one disadvantage of lithium-ion batteries? I discussed 3 in this slideshow, so protection required, cost, and transportation. That concludes my lesson on lithium-ion batteries. I hope you were able to learn a thing or two about the chemistry behind the lithium-ion battery and its applications in the real world.